Okay, here goes the review. I'm starting with problem number 10 because we had looked at the other problems together, and in fact I probably did you a disservice because I said yesterday that problems 10 and 12 you could do with cross multiplying because they were proportions. However, you're going to have a lot more work if you cross multiply. You're better off going through the same steps that you did on problem 9 and as you're going to do on problem number 11. I'm going to factor every denominator that factors. I have a GCF here, and this is a difference of squares. The reason I'm factoring the denominators, x minus 3, x plus 3, for x squared minus 9, that's x minus 3, x plus 3, the conjugates, is because I want to see what my least common denominator would be for both fractions. Now before I find that, I don't know if you'd be looking for it, but notice that your numerator is 30, a constant, and your denominator has a factor that's a constant of 5, and 5 of course goes into 30. If you notice that, you could cancel 5 into 5 one time, 5 into 30 6 times, and write this as 6 over x minus 3 equals 12 all over the quantity x minus 3 times x plus 3. If I do that, then I have a simpler fraction. I have less in my denominator here, and my LCD, can you see it? Because this x minus 3 is already in this x minus 3 here. So it would be this denominator. My LCD here, LCD, I'm going to write it out over here, would be x minus 3 times x plus 3. So I'm going to multiply both sides by that. I'm going to put it in a different color here. See if this one works. I'm going to multiply x minus 3, x plus 3 times the left side here, times 6 over x minus 3, and I'm going to multiply x minus 3x plus 3 times the right side here, which would be times 12 all over that same denominator, x minus 3x plus 3. If I do this, what will happen on the left side, you have this times this one fraction, is that you can think of it as over 1, and the x minus 3's cancel as a factor of 1. You see what remains? 6 times the quantity x plus 3. Over on the right side, it's even nicer because everything in this, in green here, the LCD cancels out with this denominator because it's the LCD. So all of this cancels with all of this, and I just get 12. Well, look how much simpler this equation is. If you cross multiply, you're going to have x squareds. It's going to be a mess. You're going to be trying to factor. You're going to be probably getting an extraneous solution. But here I don't have to worry about this because I took the time to multiply both sides by the least common denominator. Use that as a general rule, especially when the denominators have the same factors, or at least some of the same factors. So now I'll distribute. I get 6x plus 18 is equal to 12. I'm going to subtract 18 from both sides. I don't have very much space here. And I get 6x equals negative 6, and I'm going to divide by 6, and I'm going to get x is negative 1. Don't forget to check to see if negative 1 makes any of the denominators in the original problem equal to 0. If I plug negative 1 in here, I get negative 5 minus 15, that's negative 20. I don't care about the numerators, I only care about the denominators. If I plug negative 1 into here, I get negative 1 squared is 1, minus 9 is negative 8, not 0. It just can't make it equal to 0. So x equal negative 1 is my answer. Alright? Problem number 11, a lot less complicated, but again, I can do something to save myself a little bit of an aggravation here because I notice that the rational expression on the right side has a factor of 6 in the numerator and a factor of 6 in the denominator. I think before I do anything else, I'm going to cancel out this 6 with a factor of 1 and this 6 with a factor of 1. That gives me 1 over n. That means my LCD here is going to be, look at your factors. You have a 6 or an n. So it's going to be 6n. Time to get the colored pen out again. I'm going to multiply both sides, every term on both sides, by that LCD. So I'm going to multiply 6n times negative 1 over 6 minus, I'm going to multiply 6n times 8 over n. Now if you want to just put the 6n out in front in parentheses and distribute, that's fine. I'm going to multiply 6n times this side, the right side here, times negative 1 over n. So here, the 6n is like 6n over 1. The 6's cancel. I have n times negative 1 is the opposite of n all over 1. Minus Over here, the ends cancel. I have 6 times 8 is 48. And on the right side here, the ends cancel, and I have 6 times -1 is -6. You can see it coming. I'm going to add 48 to both sides, because this is linear, and I'm going to get the variable all by itself. If it was quadratic, I'd bring everything to one side. A -6 and a positive 48 is a positive 42. Now, if the opposite of n is positive 42, that means n is -42. And that's my answer. You say, well, shouldn't you check? Well, yeah, I should check. But the only thing that makes these denominators 0 is if n is 0. And that's not what I have here. Now, if you want to check your answer, you plug -42 here and do your arithmetic with fractions. Be careful with your signs. There's my answer. Up to this guy. Now, this guy in some ways is a little bit like this guy, because if you do a little bit of simplifying first, you can save some aggravation. I notice here that, by the way, this fraction over here on the right, this is 24. If I factor the denominator, x minus 2, x plus 2, I notice that my denominator here is the opposite of x minus 2. Now that's kind of weird because they have a negative lead coefficient here. I don't normally care for that very much. But I notice here that the opposite of x minus 2 and x plus 2, they're not the same, but they're opposites. I am going to factor a -1 out of the two terms here in the denominator, like a GCF. I'm -1, and that will give me x plus 2. Negative divided by negative positive, negative divided by negative positive. Now, that -1 is floating in the denominator there like it's going to cause me some problems finding my GCF. Again, I'm going to save myself some aggravation. If I was to multiply top and bottom by -1, which you can do, you can multiply top and bottom by the same non-zero number. If I multiply the top by -1 and the bottom by -1, the -1 times the -1 on the bottom becomes +1. It's as if I took this factor of -1 and just brought it up to the top. I'm going to multiply top and bottom by -1. I get -6 all over x plus 2, which I don't need the parentheses for, I put them down anyway, and 24 all over x minus 2, x plus 2. What's my GCF? Well, my greatest common factor now, after I've simplified it, well, I don't need those parentheses, let's get rid of those. I have this factor of x plus 2, I have this factor of x minus 2, and I have another x plus 2. So I have two factors here of x plus 2, x minus 2, and the x plus 2 is used twice, but it's only used once in any one single denominator, so I only need one factor of it. There's my GCF, and that's what I'm going to multiply both sides. So the left side by x plus 2, x minus 2, and the right side by x plus 2, x minus 2. Now, I always forget to mention this, but as I am working these problems out, you should have already attempted the problem and only be watching this part of the video if you're checking your work. So like when I get to the answer here, if this problem's not done on your worksheet, you should try it first. Then if you get stuck or you just want to check your answers, then you watch the part of the video that shows this one worked out. But over here now, the x plus 2's cancel. I get -6 times x minus 2. And over here, everything cancels really nice. And I just get 24. Now I can distribute through. I get -6x plus 12 is equal to 24. I am going to subtract 12 from both sides. I get -6x is equal to 12. I'm going to divide by -6, and I get x is equal to -2. And that looks like a good answer. But there's a problem. If I go back and if I plug -2 in here, the opposite of -2 is 2 minus 2, I get 0 in the bottom. If I plug -2 in here, -2 squared is +4, minus 4 is 0. This is an extraneous solution, and that was my only possible answer. So I'm going to write down in words either no answer or I'm going to put the empty sets symbol to represent that the solution set doesn't have any solutions in it, that it's empty. Now, the next 4 problems are all story problems. They're all what they call work word problems because it has to do with people working. Now, the key to working these types of problems, no pun intended, is that you have to figure out what fraction of the job each person in the story problem has done. Because the two fractions have to combine to be one job done. For example, when your Aunt Debbie and I had to rake the leaves in the backyard. Okay? She's 4 years older. She was bigger, she was faster and stronger, and she could rake probably twice as many leaves as I did. She would do 2/3 of the job, I would do 1/3 of the job, but together 2/3 and 1/3 combined to get the one job done. So we're going to figure out what fraction of the job, like in this first problem, John does, what fraction of the job Liz does, and we're going to add those two fractions together to figure out how long if they work together. Okay? So since that's your unknown here, how long is it going to take them to mop the floor together? John can mop the floor in 60 minutes. Liz can mop the same floor in 30 minutes. How long will it take them to mop the floor together? I'm going to let t, or x, or whatever variable I want, be the time working together. Okay. Now Liz is faster than John because she can get the job done in 30 minutes, which means if John and Liz work together, my answer better be less than 30 minutes because she can do it by herself. I've had students that add the numbers together. You kind of forget the fact they're working together, so they're going to be getting the job done even quicker than the fastest person can. The faster person can. So my answer better be less than 30 minutes. If it's not, I've made a mistake. Now, if they, let's say, worked 10 minutes together, then John, who can get the job done in 60 minutes, if he works 10 minutes, he gets 10 out of 60, 10/60ths, or 1/6 of the job done. Okay? Liz, on the other hand, if she can get the whole job done in 30 minutes and she works 10 minutes, she would get 10/30ths, or 1/3 of the job done. Think about it. Let's instead of 10, let's go 15. If Liz can get the job done in 30 minutes and she works 15 minutes, she's got half the job done. Okay? 15 out of 30, half the job. That's how we get that fraction. We put the time working together and we divide it by the time working individually. Okay? The time working together divided by the time working individually, by themselves. That's how you're going to figure out what fraction of the job that each of these people get done. So we're going to say that they work together for t minutes. That's how long they're working, t minutes. John can get the job done in 60 minutes by himself. So if he works t minutes, he would get t/60ths of the job done. Remember what I said before? Like if it was 15 minutes that he worked, 15 out of 60, it'd be 1/4 of the job done. Okay? Liz can get the whole thing done in 30 minutes. If she works for t minutes, she gets t/30ths of the job done. And if I add the two fractions together, like this might be like Aunt Debbie getting the leaves raked and me getting the leaves raked, we get together one job done. Because this fraction plus this fraction has to be one completed job. And you can see why this problem is in this section, because look, you get a rational equation. Multiply both sides by the LCD. Now you've got a 60 and you got a 30. Your LCD here is 60. It's nice when they're numbers. Multiply both sides, every term, both sides, by that. So, get the green pen, 60 times. The first fraction times t over 60. Oops. Let's try that again. T over 60 plus 60 times the next fraction on the left side times t over 30. Remember, you put the 60 out in front with parentheses, you're going to be distributing. And then on the right side, 60 times 1. So on this side, 60 is the same as 60 over 1. These cancel. I get just 1t or t plus, over here, I can cancel a 30 top and bottom. 30 goes in once, goes in twice. So that's 2t over 1, or 2t. And then 60 times 1 is 60. Look how much simpler that equation is. There are no fractions. I can combine like terms. This is 3t is equal to 60. Divide by 3. 60 divided by 3 is 20. Now remember, what was t representing? The time working together. How long will it take them to mop the floor together? So, working together they can mop the floor in 20 minutes. Don't forget your units. This is in minutes, not in hours or seconds, not in feet or inches, not in dollars. Make sure of your units. Now, if you understand this problem, the next three problems are practically the same thing. In fact, problem number 15 has the same two names. It has John and Liz. Okay? We're going to go ahead and I'm going to work them out. But if you understand this, again, try these problems first, and then you can check your answers by watching the video. So in the top problem here, John can clean a room in 20 minutes. Matt can clean the same room in 30 minutes. Very similar problem. Instead of mopping the floor, they're cleaning the room. How long will it take them to clean the room together? Let T be the time working together. Remember, you want to figure out the fraction of the job John does and the fraction of the job that Matt does. And because if you combine those, if you add those, you have to get one job done. Now this time John's a faster worker. He can get it done in 20 minutes. Matt takes 30 minutes. So we let T be the time working together. That means in T minutes, John gets T 20ths of the job done. Matt gets T 30ths of the job done. The numerator is the time working together. The denominator is their individual time. And again, working together, one job done. So now what I'm going to do is I'm going to solve for T here, kind of like I did down here. I'm going to multiply both sides by my LCD, which just happens to be, again, 60. I'm going to multiply both sides by 60, every term on both sides. Now, it takes forever for me to crack open that pen each time, so bear with me. I'm going to multiply 60 times T over 20 plus 60 times T over 30 is equal to 60 times 1. See, I multiplied every term on both sides by my LCD. And if I do that, 20 goes in that once, goes in that 3 times, that's 3T. Okay? 30 goes in that once, goes in that twice, that's 2T. And 60 times 1 is 60. 5T combined like terms equals 60. Divide by 5, this one's going to come out to be a whole number. I get T is equal to 12. So T is the time working together. How long will it take them to clean the room together? So working together. Oh, they can clean the room in 12 minutes. Oops, a little sloppy. Write out a short sentence on these story problems and put your units in there. Very similar problem. In fact, the first time I wrote it down, it was John and 60 and Liz, and I thought, oh, they wrote down the same problem. But in this case, this was mopping and this is cleaning, and Liz has a different time. So John can clean the room in 60 minutes. Liz can clean the same room in 50 minutes. How long will it take them to clean the room together? Well, here we go. T is the time working together. I always state the variable, because that way there's no questions at the end what my variable is representing. The time that they work together. So remember, working together divided by the individual time. So John can get T 60ths of this room clean. Liz can get T 50ths of this room clean in T minutes. And together, if they work together, they should be able to get the one room done. One job done. Now my least common denominator this time looks like it's 300. A little bit bigger number. Because 300 is the smallest number I can think of that 50 and 60 both divide into. So 300 times both sides, here, just to give you a thrill, I use the parentheses this time. I like writing it down like I did here and like I did here myself, but I know that you like writing it down with parentheses. So if I distribute, 60 goes in once, goes in 5, so that's 5T. Here if I distribute, 50 goes in once, goes in that 6 times, so that's 6T. And 300 times 1 is 300. Now it's not going to come out to be a nice whole number this time, but that's okay. We'll write it as a mixed number. Don't leave it as an improper fraction. Divide both sides by 11. 11 goes into 300. Goes in twice, that's 22. 8, bring down the 0, goes in 7 times, that's 77. With 3 left over. So 3 left over, dividing by 11. 27 and 3/11. 27 and 3/11. So, working together, you're going to get some weird answers like this. It's okay, don't panic. Just remember, it's got to be less than the shorter, the person that can get it done the fastest in their individual time. Working together, they can clean the room in 27 3/11 minutes. And there's my answer. Now I have one more of these, and then I have some story problems that involve distances and such, which actually aren't even rational equations. So they're pretty straightforward. However, if you haven't worked problems 16, 17, and so on, you work those first, and then you watch the next video.